All right, welcome to Unit 2. Atomic structure is what we're going to talk about in this unit. And our first notes of the unit were actually done in class right after the unit test. We watched a video and took some notes on atomic theory, okay, how the model of the atom was kind of created throughout the years. So if you missed that, that means that you need to get on and go to that link on that website because they do a much better job than I could do on this little iPad here. So those were the number 10 notes, atomic theory. These notes are number 11, parts of the atom. So let's take a look and review parts of an atom because remember, I know you've had this in 8th grade and I know you learned it also in elementary school. So this should be review for you, should go pretty quick for you. Okay, so we're going to start off these notes with the obvious question of what are the parts of the atom? Okay, so we have 4 different pictures here, and they all look slightly different, but they do have 3 things that are, roughly similar in the picture. We've got in the middle here, all right, we've got some spheres in the middle. Looks like 2 different colors in each picture. And then we've got, on the outside, we've got these rings and some more kind of spheres on the outside. Okay? These represent the 3 different parts of the atom that we're going to talk about. All right? Hopefully you remember that on the inside we have what are called protons. Okay? Our one color ball. And we also have what are called neutrons in the middle. Okay? And then on the outside, we have what are called electrons. So these smaller ones out here are the electrons. Okay, so those are the 3 parts of the atom, and we're going to take a look at these 3 parts in depth a little bit and talk about how we can take a look at the periodic table and figure out, how many electrons and protons and neutrons are in an atom on the periodic table. All right, so let's start off with protons. The first part of the atom that we're going to talk about are the protons. Now remember, the protons are in the nucleus and they have a positive charge. Okay, so in this picture here down on the bottom, the protons are the yellow circles with the little plus sign in the middle. Okay. These are the protons here. There's 1, 2, 3, 4, 5, 6, and there's one hiding in back here, 7. Okay, so there's 7 protons in this representation of an atom. Okay, so they're in the nucleus. That means that they're inside, in the middle here. Okay, so they're in the middle of this atom. They have a positive charge. All right. Now, protons are one of the parts of the atom that account for the mass. So what that means is that it's a heavy particle inside of the atom. Okay, so the nucleus is the heaviest part of the atom, and inside the nucleus there are, remember, protons and neutrons. And so the protons are going to account for the atom's mass. They're going to be part of the atom's mass. Another key thing for protons, all right, if you want to start in your notes, is that the number of protons give you the atom's identity. All right, if you look at a periodic table, it's going to tell you the number of the protons up. It's going to be the small number up on top. Here, let me show you. Okay, so you see here, this is the symbol for neon on a periodic table. So this top number here is going to tell you the number of protons, and it's going to give you the atom's identity. Only neon is number 10. Okay, if you look at any of the other numbers, it's a different type of element or a different type of atom. For example, number 11 is sodium, all right, and number 9 is fluorine. Okay, so the number of protons gives the atom's identity. It'll tell you what type of atom or what type of element you're working with. Okay, so that's huge. It's really, really important to remember. Okay, let's take a look at the other part of the nucleus, which are the neutrons. All right, so again, the neutrons are also in the nucleus, and neutrons are neutral, so they have no charge. So if we take a look here at our picture, remember we said the yellow ones were the protons, so that means that the orange ones here are the neutrons. All right, it looks like we have 1, 2, 3, 4, 5, maybe 6, okay, 5 or 6 in this nucleus. And you can kind of see that we don't have to have the same number of protons and neutrons in an atom. We will talk about that in the next set of notes. But what you do need to know, or need to remember, is that neutrons are in the nucleus and they have no charge. That means that they are neutral. So take a look here. They both start neutrons, neutral. Means they have no charge. Kind of an easy way to remember the charge of a neutron. Okay. Now, neutrons, again, are in the nucleus, so that means that they are going to account for the atom's mass. So there are two things that make up the mass of an atom, the protons and the neutrons. All right, so now we have here that, again, those neutrons are going to account for the atom's mass. And like I said earlier, we're going to put in our notes that atoms can have a different number of neutrons without changing its identity. So the protons are the identity maker. Okay, how many protons an atom has will tell you what type of atom you're talking about. The neutrons just add weight. Okay, it doesn't matter, if if there's 2 neutrons versus 8 neutrons. It just means it's a skinny hydrogen, atom versus a fat hydrogen atom. All right. So again, the neutrons don't change the identity. All right. Now let's take a look at the third part of the atom, the electron. All right, electrons are the third part of the atom. Remember, these guys are outside of the nucleus. Okay, it's all these little tiny circles that we see here outside of the nucleus. All right, these are the electrons. Super important, along with the protons and neutrons. So let's take a look at some of their features. Okay, so electrons outside the nucleus, they have a negative charge, all right? So we see that there's 2 different charges in an atom. We have a negative charge here on the outside and positive charges in the middle, all right? We are going to soon find out that the number of positive charges in the middle must equal the number of negative charges on the outside in order to make what we call a neutral atom. If there are unequal positive and negative charges, it's actually not an atom. It's what we call an ion, all right? So we must have an equal amount of protons, positive protons in the middle, and negative electrons on the outside, okay? So let's take a look and write down how electrons account for mass, and the fact that, again, remember, electrons can be either lost or gained. And we'll talk about that a lot when we talk about bonding, especially ionic bonding. But let's put, just a few more features of electrons down in our notes. All right, so we have in our notes that electrons are so tiny that they account for little to no mass, okay? So when we're talking about the mass of an atom, most of the mass is here in the nucleus. Those electrons are so small that they don't really matter for mass, okay? So when we talk about where the most of the mass of the atom is, you're going to want to say in the nucleus, all right? And then our last feature of electrons is the fact that they can either be lost, okay? So electrons can lose atoms, or they can, gain or take atoms from other atoms, or electrons from other atoms. But whether they have either lost electrons or gained electrons, it's not going to change the identity of the atom. Because remember, what part of the atom tells you the identity? It's the protons, right? It's protons are the only ones that give identity. So if you change the number of electrons, doesn't matter, okay? Just means that, it's, a positive lithium ion versus a negative lithium ion or something like that. So it doesn't change the identity of that atom, all right? Now let's take a look a little bit further at those element symbols on our periodic table and take a look and see what they tell us about atoms. All right, so here we have the symbol for neon. This is what it looks like on your periodic table. It has the 10 on top. We have the Ne in the middle, and then we have 20.18 here on the bottom. So we're going to take a look and see what each of these three things on the periodic table tell us. All right, we'll start here with the 10 on top. The 10 on top tells us the atomic number. Okay, so that is the atomic number of the element. All right, we'll take a look at atomic number in the next question. Right now we're just going to take a look and name each of the parts. Okay, now the middle, okay, the letters in the middle tell you the element symbol. It's like an abbreviation. Okay, so it's it's akin to rather than spelling out California all the time, okay, we can just put capital C, capital A, right? It means California. Everybody knows it. You learned it since 5th grade, all right? Now, here are some new abbreviations that you're going to have to learn. Not memorized, by the way. You do not have to memorize the periodic table. You will always have one handy for everything you do. So don't worry about memorizing it, although by the end of the year you will know a lot of them just by heart from pure practice. All right, so the Ne in the middle here is the element symbol for neon. All right, now the bottom number here is a decimal number, if you see. And this decimal number tells you the average atomic mass. Okay. Average atomic mass. Please put average there. We're going to talk about why it's an average in lessons coming up, but it's the average atomic mass, all right? That's why it's a decimal and not a whole number, because it could change depending on the different kinds of atoms we have for neon. So we'll get there, but just so you know, it's average. All right, so let's talk about the atomic number and atomic mass in the next two the next two questions of these notes. All right, so the atomic number is the number of protons in the nucleus. So down here in our example, okay, we said we had 1, 2, 3, 4, 5, 6, 7. Right there in the middle, there's another one hiding, kind of in the middle of all those little circles. We have 7 protons in the nucleus. All right. Now, remember, again, the atomic number is the number of protons, so that tells you that the atomic number is also the identity maker of our atom. All right, so there it is. It tells you what atom or element you're working with, so it gives you that identity of the element or the atom. Okay. Now, remember, I also said that the number of electrons around here, okay, has to equal the number of protons in a neutral atom. Okay, so just like there are 7 protons in the middle, there are also 7 electrons on the outside. So that top number on our periodic table not only tells us the number of protons, it also tells us the number of electrons. All right. So again, it also tells us the number of electrons in a neutral atom, okay? And you have to remember that it's just like in math, all right? Protons or positive charges must equal electrons or negative charges in order to get no charge, okay? So if you want a positive number and a negative number to equal 0, okay, you have to have like positive 3 plus a negative 3 equals 0. Those numbers have to be equal. Just like in chemistry here, the number of protons or positive charges you have here in the middle must equal the number of electrons on the outside in order to get no charge, okay, or have zero charge. All right, so that's what the atomic number, that number on top, will tell you on the periodic table. Now let's take a look at atomic mass. Okay, so our next question, what is atomic mass? Well, atomic mass is the number of protons plus the number of neutrons inside the nucleus. Because remember when we were talking about the two different parts of the nucleus in there, we said that there's protons and neutrons, and both account for the mass. So atomic mass is the number of protons plus the number of neutrons. Now, these guys are measured in their own different kind of measurement system, okay? Because if you think about it, can you take one single atom and put it on a scale to measure it in grams? Probably not, okay? Since it's even super hard to even see one single atom using an electron microscope. So there's no way that you're going to take one little atom, put it on a scale, and get a nice little, number on the scale. So instead of using grams, protons and neutrons are measured in AMUs. Okay? Now, AMU stands for atomic mass unit. Okay, so atomic mass unit. So they have their own units because, again, we can't take a single atom and put it on a scale, let alone a single proton or a single neutron and put it on the scale to measure its mass. So we call it atomic mass units, AMUs. Now, the three different parts of the atom have three, they have their own AMUs. One proton equals one AMU. One neutron is also equal to one AMU. Okay, so mass-wise, they account for the equal size or equal proportion for the mass of an atom. Okay, now electrons here. Remember, electrons have very little to no mass, so they are going to be represented as 0 AMU because they are so tiny that they almost have no mass. Okay. So again, this reiterates the point that the only parts of the atom that will have mass are protons and neutrons, and they are both found here in the nucleus. Okay? All right. One last thing we need to know about atomic mass was what I was saying before when we were looking at the periodic table card for neon. Let me bring that back up. All right, here we go. So if you remember this, we were talking about this bottom number down here, which is the atomic mass, and I said it's the average atomic mass because atomic mass can differ depending on the different isotope of that element that we have, and we'll talk about isotopes in the next lesson. But for right now, you just need to write this down. That the atomic mass can vary with different atoms of the same element because different atoms can have different numbers of neutrons. Okay, remember we mentioned it before when we were talking about the parts of the atom, that the number of neutrons can vary without changing its identity. So, the average atomic mass down here is a decimal because we're going to have different atoms of the same element with different number of neutrons. Okay, and we'll talk about that in the next notes, which are the isotope notes. Okay, now we've got just one last question, and it's super easy. Those of you who are pretty smart in math can figure this one out pretty easily. But we're going to put it in our notes just in case you may forget or not realize how to do it. Okay, we're going to talk about how do you find the number of neutrons looking at the periodic table. Okay, so again, our last question, how do you find the number of neutrons? Now, if you recall, we had said that the top number here on a periodic table is the atomic number, so it tells you the number of electrons and protons, okay? But there's not any of those, none of those numbers tell you explicitly or right away the number of neutrons. We have to do a little thinking here, okay? Now, we know that the mass is the number of protons plus neutrons, okay? So, and if the top number tells you the number of protons, then we just need to do just a little subtraction. To find the number of neutrons, you take the mass and you subtract the number of protons from it. So let's put that in our notes. All right, there it is. The number of neutrons is equal to taking the atomic mass, which again is that bottom number right here. So taking the atomic mass and subtracting the number of protons, which is the top number, and then you get the number of neutrons. So, for example, in this this thing right here, it's 20. All right, we're going to take whole numbers, and we'll talk about why next in the next notes. But basically, you can't have like half or even a portion of a proton or a neutron. It doesn't. It's all or nothing. Okay, so we can't have 20.8 or 1/8 protons and neutrons. Okay, none of them can be a part of a whole. All right, so for example, let's just say if we took 20.18 minus 10, right, you would get 10.18 neutrons. However, we can't have a part of a neutron. Okay, so we're just going to drop this part, and we're just going to say 10 neutrons. All right, we'll talk a little bit more about that when we talk about isotopes. But you got to take the whole numbers, okay, because again, you can't have a part of a proton or a neutron. All right, and the only reason why we have a decimal there is because it's taking averages, average masses. All right, so that's kind of tying it all together. All right, so in this example up here, for neon, okay, this particular atom of neon would have 10 neutrons, okay, or could have 10 neutrons. All right, so that's the end of these notes, and we'll see you tomorrow in class for the activity.